All right, gentlemen. This list of EQs, basic understanding 24 volt control volt circuits. If you notice you don't have any supplementary materials, there's 1,000 YouTube videos out about 24 volt circuits. But we were building diagrams on whiteboards and on gray boards when we were working on this. So hopefully you can think back enough to kind of remember talking about these a little bit. What is the control voltage and how does it differ from supply voltage? Well, the control voltage is created at the transformer, and it differs in that supply voltage, like the primary voltage supplying this transformer, is usually typically not always a higher voltage, but it is the load voltage as well. It supplies the low voltage to run a motor, to run an inducer, to run whatever your load is. Where the secondary windings are the control voltage, that tells a switch. And just remember, a switch is a switch is a switch. It can be a relay switch, a contactor switch, a pressure switch. It tells when you want the load to run, when you want the compressor to run, when you want the gas valve to open, when you want the blower motor to come on, etc., etc. So control voltage is usually moving an inductive load on a coil on things like relays, contactors, circuit boards, thermostats, etc., etc. Where supply voltage is actually supplying the voltage needed to do the work. The low voltage going to a compressor, a blower motor, an inducer motor, or what have you. What voltage do you typically find in residential like commercial applications? You typically find 120, 208, or 240 single phase. Does control voltage always need to be 24 volts? If not, what other voltages might you find? 99% of the time on commercial applications it's 24 volt AC. If you have anything that modulates, it's 24 volt DC. In commercial and refrigeration, it can be much higher, all the way up to usually no higher than 240 volts, AC or DC. But 90% of the time, 24 volts. Don't assume, look at the data tag. Where in the system does the control voltage begin? That good old trusty dusty transformer. It always begins at the transformer, so do not forget that. Your primary voltage, your supply voltage comes in, secondary control voltage comes out. Okay. List at least 5 components that use control low voltage. Inducer pressure switches, low pressure switches, high pressure switches, relays, contactors, solenoids, reversing valve solenoids, T-stats, circuit boards. List goes on and on and on. Lists all the components that you can identify that use both control and high voltage simultaneously. Meaning, going back to that relay diagram. Let me see if I still have it pulled up. I don't think I do. Going back to our relays or our contactors, anything that has a low voltage or control coil and then switches on it, use both simultaneously. So the coil creates the magnet that moves the actuator, takes normally open and closes them, takes normally close and opens them. Those would be things like relays, sequencers. Control boards have both high and low voltage. That's different. Thermostats do not. Safeties like pressure switches do not. Gas valves do not. It's only things that have switches for high current, like contactors, relays. Let's see here. Which device is used to protect low voltage component from direct shorts to ground in contact with high voltage? That's a good old trusty fuse mini breaker. And where should the fuse and mini breaker be located in the unit? It's this important that I say it over and over again. It needs to be in the hot leg immediately leaving the transformer. Immediately. So, for example, you got 120 coming in, 24 volt common and hot. If this is your hot, you would cut this and stick the fuse right in the middle of it. Any questions about these essential questions? I know I'm moving fast. We got one more. Feel free to ask a question at a later date. Email, text, or call me.